Question 14a. Prove by mathematical induction that 8 to the power of 2n plus 1 plus 6 to the power of 2n minus 1 is divisible by 7 for any integer n greater than or equal to 1. The first step is to show the statement is true for some value of n, and we can choose n equals 1. When n equals 1, 8 to the power of 2n plus 1 is 8 cubed, and 6 to the power of 2n minus 1 is 6 to the power of 1, or 6. Now 8 cubed plus 6 is equal to 518, and 518 can be written as the product of the factors 7 and 74, which means that 518 is divisible by 7, hence the statement is true for n equals 1. Next, we assume the statement is true for n equals k. That is, 8 to the power of 2k plus 1 plus 6 to the power of 2k minus 1 is equal to 7a, where a is an integer. Next, we show the statement is true for n equals k plus 1. So in the assumption where we have k, we're going to replace that with k plus 1. So 8 to the power of 2 outside of k plus 1 plus 1 plus 6 to the power of 2 outside of k plus 1 minus 1 is equal to 8 to the power of 2k plus 2 plus 1 plus 6 to the power of 2k plus 2 minus 1. So that's expanding brackets there and there. Which equals 8 to the power of 2k plus 3 plus 6 to the power of 2k minus 1 plus 2. All I've done is I've just swapped the positive 2 and the negative 1 around. And that equals 8 to the power of 2k plus 3 plus 6 squared multiplied by 6 to the power of 2k minus 1. And this equals 8 to the power of 2k plus 3 plus 6 squared multiplied by 7a minus 8 to the power of 2k plus 1. And that's from the assumption. Let's go back to the assumption. All I've done is I've rearranged this equation and made 6 to the power of 2k minus 1 the subject of the formula. What that means then is that the term involving 6 to the power of 2k minus 1 can be eliminated or can be substituted instead for a term involving 8 to the power of 2k plus 1. So all the terms which have k in the index all have a base of 8, and that will simplify the proof. Now expanding the brackets, that equals 8 to the power of 2k plus 3 plus 6 squared multiplied by 7a minus 6 squared multiplied by 8 to the power of 2k plus 1. And that equals 8 to the power of 2k plus 3 minus 6 squared multiplied by 8 to the power of 2k plus 1 plus 6 squared multiplied by 7a. Now factorising out 8 to the power of 2k plus 1 from this term and this term, that equals 8 to the power of 2k plus 1 outside of 8 squared minus 6 squared plus 6 squared multiplied by 7a. That equals 8 to the power of 2k plus 1 multiplied by 28 plus 6 squared multiplied by 7a. Now at this point we can factorise out 7 from this term and this term. So that equals 7 multiplied by 4 multiplied by 8 to the power of 2k plus 1 plus 6 squared multiplied by a, which is divisible by 7. Therefore, by the principle of mathematical induction, the statement is true for all integers n greater than or equal to 1.